Hello, in this video I will show you how to design a 4-bar linkage that moves the coupler between the three positions specified in figure 2.63. We will find the required positions of the ground pins and the lengths of each link that later will be used to be moved, or in this system we will be adding a diode. Okay, so that will become a very interesting project, I think. But at the right side of my screen you will see the final step to create this mechanism. We saw that in class, and both the images and also the problem come from the introduction to mechanism design with computer applications from Eric Constance and Carl B. Dyer, which is a very recommended book. Okay, so instead of trying to understand from this this slide what is the procedure, maybe you already know the procedure, but I will review it using the actual problem that we have to solve, okay, or to meet with the requirements of this problem. So I will go to Fusion. I think that you are still not looking at my Fusion screen, but you will. So that's the starting window, and then we will create one sketch. We will select the XY plane, and then I will start with the second position for the link. It measures 50 millimeters, and it is totally horizontal. Okay, so that's the easier one to draw. The second one will be more or less at this position. I will tell the software, you know, this has to be of the same length than this one, and I will create one construction line and set the angle for this link to 20 degrees, okay, based on the assignment from the problem that I just showed to you. So the next point, or the next step, will consist on adding one vertical dimension of 60 and one horizontal dimension of 75 millimeters. And I think I expect to be remembering correctly all those values. But then let's go to the third location or position. Oh, sorry about it. Then we will add this extra reference line, which actually could be the second position, but let's create this construction line, and once again the angle will be 20 degrees. And once again I will tell the software, you know, this has to measure the same as this other link, okay. And the dimensions this time are 25 horizontally and 10 millimeters vertically, okay. So I hope to be using the right location: 60, 75, 25 and 10. 20 degrees for the two angles, so 60, 20, 75, 25 and 10. So let's go back to Fusion, and it's let me go back to Fusion. 75, 60, 25 and 10, and also we have a length of 50 millimeters and two angles, or the angles for the two positions 1 and position 3 are 20 degrees, okay. So I think we have the right initial drawing. Then I will finish this sketch, and I will create a second sketch. That's something that we may have not been using in our course, but you know, I have found that it brings some advantages. For example, I will create, in this second sketch, I will create only the lines that go from A1 to A2 and from A2 to A3, and these two lines will be construction lines, okay. So next we will create the lines which go from B1 to B2 and from B2 to B3 using a third sketch. also a plane sketch, then well, and a sketch on the plane XY. So this time we activate the construction lines, and we have these other lines which will be used in the next sketch for creating the bisectoring lines. Okay, so once again, using construction lines, something that I want you to observe is that if I go in this direction, creating the lines in this direction, let's call them downside, my lines will never meet. Okay, so actually, let me take out the second set of lines. You will see that I have to join the bisector lines which come from this line and this other, and if I go like this, they will never meet. So that's why I will create the lines centered and perpendicular, but going to the upward direction. And these symbols are telling me that I am creating correctly those lines. I need both the perpendicular and the middle symbols. Okay, so now I can trim these parts of the lines away, and I have found the origin for the link number 2. Okay, so that's one part. Now I can deactivate those lines and work with the other set of lines, and this time, since I continue in the same sketch, I can continue creating lines, and one of the lines will be at the middle here, and then perpendicular. You know that part very well, and the next one will be at the middle here, perpendicular. The symbols are there, they are showing me that I create correctly these two bisecting lines. Okay, so now I have the regions for link number 2 and link number 4 defined. I can come and attach those two origins, and the next step will be creating circles that go from here to here. Okay, and these circles define any point that my joint A will be touching as this mechanism moves. Okay, so we want it to pass through point A1, point A2, and finally point A3, and it seems like it's working now. So that's correct for the origin of for link number 2, and let's do something similar with the origin of link number 4, and this time I will go up to this point, and once again this circle describes all the points that my joint B can describe. Okay, so that one should not pass through A2 but over B2, which is happening, and finally passing through B3. Okay, so sorry for not labeling these all these points, but once again that's A, B, the origin for the link 2, origin 04 for the link 4, and I think that this is working. And the next step is maybe taking advantage of the sketches to create a 5th sketch, and in this one we are going to finally define our mechanism. Okay, so now that we have the origins, I can create my link number 2 arbitrarily oriented, and then we will get this circle, which is too much, we don't need it. And then we have this other circle, but it comes from another sketch. So I think that now we can turn on the sketch 1 with the 3 different positions for our coupler, and now maybe these 2 circles, which are clearly defining the positions for the joints A and B, those circles will be useful, but now I need a third circle. Okay, this third circle will have a diameter of 100, and the reason for having 100 is that our coupler, you remember that our coupler has a length of 50 millimeters. So now I am defining a circle, auxiliary construction circle too, which tells me where my joint B is at this moment, and it will be at the intersection of these two circles, the third circle that I just created and the second circle, which describes the different locations for link 4. Okay, and since the joint that I am looking for is attaching links 3 and 4, it has to be on any of these two intersections. So let me create one line from here to here. I will try to be very careful, and then I will create the next line from this point to this origin. Okay, and maybe that circle is not needed, and in this case what I will do, what you have to do, is using exactly the values that the software has found. You cannot change them because the way we design the workflow that we are using is based precisely on the graphical solution for or design or synthesis for this mechanism. So you have to leave the values just as they are, 50 and 51.44. Okay, so if everything is okay, that should move. But dragging the whole mechanism, and this doesn't happen because when we created this line, the line was defined from the circle, not from the end of this coupler. Okay, so let's delete this line and finally create one line that correctly describes our link 2. Okay, and that once again has the same length, but this time it should work correctly. Okay, so if you remember, we have to pass through this first position for the coupler, so we have done that. We have succeeded for the second position, and now we are only missing the third position, which we have met correctly. Okay, so now we have defined the 4-bar mechanism which meets the requirement from this problem, or obtained from this problem. And maybe you are wondering, what is the length of the missing link, which is link 1? And with that one you could proceed to check if this mechanism meets the Grashof criteria or not. But regardless of that, we will make, in the next video, we will force this mechanism to go from the two limiting positions 1 to the limiting position 3, which is 1 is that one and the 3 is this other, and it will oscillate between these two limiting positions and will pass through the required position number 2. But that's what we will get. Let me show you that. Maybe it's easier if I show you the result here with this other mechanism which has already been prepared, okay, or generated, and you can see what I was trying to explain. Now we have a diode, and the diode is moving our coupler. Don't forget that the coupler is the one that has to pass through these 3 positions. Okay, and then when it gets up to here, it comes back. Okay, so that's what we want in your project. It's not required by the problem that we are trying to solve, but it will get you a very interesting mechanism which was designed by yourself based on any application. And I think that when you prototype this and move it and check the motion and how it solves the required positions, you will be very satisfied with the result. Okay, so that's it. I will stop this video and we'll continue with the second part of the mechanism synthesis project, adding one diode in a second video. Okay, Thanks for watching.